So I just finished wiring my solar setup and it was a bit of an adventure. Mainly because of the way I use the system, but I figured I'd share my setup along with some thoughts and lessons learned to help you guys out in case you run into something similar. Now it makes sense to start with my use case to give you some context on the build. My system serves two functions. First and primarily is to act as a home battery backup when the power goes out, but since that's a rare occurrence and to get the most out of my investment, the secondary application is to power a small set of loads when not on emergency duty. Now this design brought up a few challenges. For one, I wanted a system that could backfeed my main panel, but also run completely independent when I wanted to power off-grid loads. But first, let's go over the specs. Now, because I want to power my main panel, that means I need 240 volt split phase. I already had one inverter on hand, so the easiest way to accomplish this was to just buy a second inverter. Now, here's my first gremlin. My system is actually 24 volt because I already had some of these components from a previous project. For me, it ended up being cheaper to build this out rather than starting a 48 volt system from scratch. Now, if I were to design this from the ground up, then yeah, I'd go 48 volt and save myself some copper and bloody knuckles. So we have our two Growatt 24 volt 3000 watt inverters. Put the model number on the screen here. Now these are powered by two Signature Solar EG4 24 volt 5 kilowatt hour batteries, providing a total of 10 kilowatt hours of battery backup, or enough to power my house on limited loads for about 2 days. Between the two is a steel wireway, obviously not required, but with small kids in the house, it's a nice safety feature. Now I'm going to break down the review of the system in 4 parts: the inverters, the batteries, the DC wiring, and the AC wiring. Now I've timestamped the video so you can jump straight into any one of those topics directly. So first up, the inverters. I have the inverters installed on this kind of half wall, which is a little bit unique. It's basically just 2x4 construction with hardy backer mounted to it, and it's tacked into the floor joist above and secured to this industrial shelving below. While it's kind of a floating wall, it's actually very secure. I did this because it makes the inverter more accessible to service rather than having to reach all the way back over those shelves to the foundation wall. One of the side benefits of this is that it opens up the area behind the half wall for cable management. Another interesting note on the mounting is that I made these standoffs for the inverters out of aluminum, and they sit about an inch or so off the wall. Now I did this for 2 reasons. First, it allows better airflow and cooling, and second, it's another space that can be used for cable management. So everyone complains about the serial communication cables that need to be run between the two inverters. You can see how neatly I was able to accomplish this using the space behind the inverter and some flex tube I had on hand. I don't have any of my solar panels installed yet, but you can also see I've put in a PV disconnect switch and wired it up in the middle there. So this part of the install was actually fairly straightforward. Really, the biggest issue I had was that the inverter shipped with the ground and neutral bonded on the AC out. Since I wanted to backfeed my main panel, which also has a ground neutral bond, I needed to disconnect that bond in each inverter. If you're interested to see how that was done, check out my other videos on that topic. Next up is the batteries. The most interesting part here is the rack. Since I only went with 2 batteries, the 3 battery rack from Signature Solar was just a little too much. Plus I really didn't have a good place to put it, so I decided to build my own. Now this rack is pretty simple. It's just made out of 2-inch angle iron. I cut a few pieces and bolted them together, and really it works perfectly. I also installed 2 bus bars, one on each side, which connect up to the wireway using 2 AWG cables. Okay, let's talk about charging. I don't have my solar panels installed yet, so right now I need to charge from the grid. And initially I wanted to use the AC input on the Growatts to charge the battery bank, but I quickly found out that you can't limit the charging amps on lithium batteries. So for me, this is a problem. Since I only have a 20 amp circuit available, you really need a 40 amp circuit to do it correctly. I had to find another way. This leads me to my second mistake. I decided to buy a dedicated battery charger from Signature Solar, but I bought the little one, which was actually still expensive. And it only pushes 250 watts into the batteries, so a full charge can literally take days. So I'll be spending more money this year to upgrade that piece. Moving on to DC wiring, the basic rundown is this. Each inverter's positive runs to a breaker, then to a bus bar inside the wireway. This bus bar in the wireway is wired down to the bus bar on the sides of the battery rack with 2-watt cable. The biggest challenge with the wireway is its size. It really restricts the amount of workable space, and running 2-watt wire was a huge pain in the ass. And so was all the cutting of all the holes with step bits. But as you can see, each inverter runs to a 150 amp DC breaker. Now, most people would probably go a bit higher than 150, but you size for the load. And I'm not going to be putting more than roughly 100 amps through each inverter. You can also see that I did have to cut standoffs for these breakers to allow the cables to route correctly. Again, a pain in the ass. The real challenge was fitting the 2 bus bars in here. It is almost impossible to get an orientation that worked. In fact, I originally started with 2 larger Blue Sea Systems bus bars, which I just couldn't make work. So I ended up ordering these custom bars from a battery shop in Connecticut. In terms of wiring, I'm using 1/0 cable from the inverters to the bus bars, and as I said, 2/0 down to the battery bus bar. Each inverter is rated to pull a max of 146 amps, but as I said, I only plan on drawing 100 or so amps out of there, so 1/0 should be sufficient. The cable going from the bus bar on the battery racks to the batteries is also 1/0 gauge. Now the AC side. This is where things get a little funky. As I mentioned, I want these inverters to essentially be a floating system that can power either my house or a dedicated load center. The big challenge here was grounding and bonding. My load center has its own earth ground separate from my main panel's earth ground, which is on the other side of the house. So the challenge became, how do I float the inverters between both panels without permanently grounding to either one? Now I can't connect my load center to my main panel because they each have their own earth ground, and that would create a ground loop, so I need to keep them completely separate. The best way I figured to do this was to use a generator cord to connect the inverters to either the main panel or the load center, and the key here is that only one can be connected at a time. So the inverters will essentially inherit the ground of the panel that it's serving. So that's what this little setup is doing. The AC out from the inverters comes into a 30 amp dual pole breaker, which powers this L1430 outlet. The generator cable then runs from that outlet to a panel, which has its own breakers to allow power in and run loads. On the backfeed side, to power my main panel, I've run 10 gauge wire through conduit over to a manual transfer switch. This switch allows me to select source power from either my inverters or my generator hookup, which is out in my garage. The idea here was most power outages in my area only last for a few hours and typically happen on cold, snowy, and windy days. You know, the kind of days you really don't want to be outside firing up a generator. So I can run my batteries either until the power comes back on or until I need to switch to that Jenny, at which point I can power the home and then recharge the batteries, rinse and repeat. So the transfer switch is connected directly to my main panel, which uses an interlock kit. So it prevents the main breaker and the breaker controlling the transfer switch to be on at the same time. So that's it. Probably not your typical setup, but hey, it works for me and hopefully it helps you out with your build. As always, thanks for watching and feel free to leave questions or comments below.